math stuff. And then we'll get you back to those breakout rooms because group work is good. All right, so we are going to dive into some of the other language built-in features. So just so you know them, because if you didn't know them, then you'd be struggling trying to do some of the stuff on your own. And when some of the stuff is built in, which is great, and there's a lot of stuff like this. Like I said, hoisting is a very high level concept. These now is getting more towards like, common things we can use in the language. So this hopefully should be a little bit lighter. All right, so we want to look at these built-in features from the language that can save you a lot of time. As you already know, with JavaScript, it can change the type on you. It'll try to convert it down, do that cohesive, what was it called? Coercion type conversion. Coercion will try to assume whatever you're passing in. So if you pass in a number and you try to concatenate it, it'll basically convert it to a string and all those things, which makes it pretty awful when you're trying to add two numbers together. Sometimes it'll convert it right to you. As we said before already, when we were working with some of this stuff, right, if we had just even add two numbers here, and we go to invoke it, and we said something, we did, it would take this as well. I said xxx plus 100, and if I did that, it'll just concatenate it, because what it does is it takes 100, it assumes that it's a string, it does a type conversion on it, and all of a sudden now we're in trouble, right? Can we also do something like true, 5 plus true? What happens there? It'll probably convert true to 0 and give you 6. That's weird, because that's true, because if you remember, true in that binary format, that logical and or gate, the 1 and 0, true is equal to 1 and false converts into 0. This is problematic when we are trying to do fine-tuned calculations, like, converting 5 decimal places using pi. Very problematic. Yes, thank you. Someone shared their solution, which is cool. Right, so let's look at this. So we kind of danced around some of this already in our other labs, but there's a concept called number in JavaScript that's built in. We maybe looked at it, maybe not, but if you were using some of these already, we kind of already know a little bit about it. So when you use as a function, this number can convert a string or any other value to a numbered type. So it's a way of kind of casting it back down. If the value can't be converted, it returns NaN. If you remember from previously, NaN stands for not a number. It's a strange type that gets passed around. You may see this. I saw this being passed. I don't know. I saw it on some shopping cart. It wasn't. I forget what it was. Some e-commerce site. I went to add it, and then it just exploded on me, and I just saw NaN everywhere. So some conversion, something happened in the back end, and it just blew up. So number is a primitive wrapper object used to represent and manipulate numbers like 37 or negative 925. So here's case in point. Number, if we give it a string, it will return 123. Yes, if this expression gets evaluated down, it'll be 123 equals to 123, which is true, which is good. However, number in unicorn is NaN, not a number. Number undefined is NaN. So it's a nice way of casting something quickly. So for instance, in this example here, if we had, what do we have before? Some string plus 5, now plus, add 2 numbers. So we have some string plus 5,000. That's ridiculous, but it'll give us some strange some strange answer. So if we wrap this in a number, right? If you probably figure out what might happen is it probably should explode on us a little bit here, because it's going to try to convert this this long string into a number, and it should give us NaN. So it did, not a number. Right, but however, if somebody happened to pass, as in your user input, when you had the prompts, right, this would be a quick way to cast something down. So if we get this, it'll cast it down and it'll give us 6,000 because it converts this all for us. So that's great because we don't have to test for it. So a quick little conversion is very helpful here. So built-in feature there. Again, really understanding any language is understanding the small terminology and words, and then as you kind of experiment through them all, you kind of develop the vocabulary to do things, do great things, right? So this is the markup for the global. It's a global object. It basically has a little syntax here, how you can use it in the same way. A little bit more to it as well. Again, this is the web docs. Please use them whenever you see something that, right, there's a whole bunch of static properties on that we haven't even looked at. There's a lot more than what I'm showing you in here, and I don't feel to go through every property, but just know that if we, there are a lot of things built in, right? Once I show you one, you can go off and look at another. So what's this one? If I do this, run it. So it gives us, so this would be considered like a constant, a static constant. So you can imagine somewhere in that number class, there's a constant up there, right? Something that's a global variable inside of that object that is set to that, right? So it's static, meaning, so static's a terminology and more advanced terminology. Basically, it's something that you don't have to instantiate. It's basically part of it. So anyhow, I'm getting a little deeper than I thought, but yeah. So number converts things down, which is great, built in. Parse int. So this method we already kind of talked about already. You may have already looked at the web docs in this. So it'll take a string and parse it into an integer. So this is very helpful. We may have used it in some of our labs. So as you can see, 10 converts to 10. String 10 decimal 33 converts to an integer 10. Now, if you don't remember the difference between an integer and a float or decimal, just refresh yourself a little bit. Integer has no decimal value here, so it can do some weird things. So it can take, it does some weird concatenation there on that, or some roll up 10, 20, 30. It returns 10 years. I guess it looks at the first occurrence of a number and it converts that and ignores the rest. And then if it doesn't find it, I guess years 10 returns NaN. So this is a very useful one as well. If you want to parse int something, you could directly, now, if you notice there, if we passed in an integer value here, it'll probably, let's get rid of this. If we passed in, 1, 2, 3, 4, 5, what's going to happen here? It's probably going to concatenate all of that. If I want 1,000, which is an integer plus this decimal, it's probably going to give me this. So maybe that's not what I want. Maybe I want to directly parse that. So maybe I might not want to use number in that case. Maybe I want to use parse int, right? So this basically rounds up, cuts off all this part here, and gives me what I want. So then you could decide, well, maybe I don't want this as well. I just want to convert them all to integers nice and cleanly. We did exercises where we were taking input from the users in some other lab, where we were taking the first number, the second number, when we had the interface with the pop-ups. But those pop-ups, the Windows prompts return string. What do you do with that string? You know that situation. You've been into that, right? Interesting fact though about this is, I know you don't know, some of you don't know a lot about classes or objects, but the number is an object, and really this would be the same thing as doing number dot parse int. It's on that object. It's actually part of it, but you don't have to do it in this long way. The compiler knows what this is, but because it's a built-in object, so you don't have to do that right there. It'll basically know where to find that object in the global scope. Remember, we're the global scope, so JavaScript has all these built-in global objects that you can call if you so desire. So that's a nice way of just converting everything down to integers, and that's built in. So that's a good method there. All right. So this other one here, this is a good check to have, is NaN. So this is a way that you can actually determine whether the input is actually a number. And you can do some conditional operations on it. You can you can put, an if statement. If the number is not a number, then exit out of maybe you need to exit out of your function. Maybe you need to do a console log. Maybe you need to do something called a console error. Just to say, hey, like, you're providing something that this piece of code block, this building block, this function cannot use. Therefore, I'm going to capture it first, so that the compilation of the code doesn't fail. So it's a way of checking your code and handling it in a way. And we'll get into some of that more advanced stuff, error handling and debugging, in section 2, part 2. But anyhow, this is a great one to have. It's built in. Quickly can check whether what you're passing is a number or not. So it's a more robust version of the original global isNaN. Number.isNaN. Okay, so they're saying there is a global variable floating around called isNaN, but then they also kind of reconciled a method inside of the number, but they're the same really, except the number one is a bit better, maybe newer, but doesn't matter. You can use it directly. So in this example, 1, 2, 3, is it not a number? Not checking if it's a number. 1, 2, 3 is false because it is a number, so that's false. Negative 1, 2, 3 is false also because it's a valid number, so it's the opposite. 5 minus 2 will probably evaluate to 3, and then we check, is that not a number? False. 0, false. String, if you notice that, probably does that conversion down to the bit 0 number, and then it says false. So it does a weird conversion on you. You remember JavaScript does that. However, hello string is truly not a number. This date is truly not a number. Empty string, if you remember the truth policy, yeah, that you may need another check there, but for this check, that'll convert to a 0, and it'll say, okay, well, the 0 is a number. This is the weird stuff that happens with the truthy falsy. Remember, this is where it gets weird. This will convert to a 1. It'll say, okay, it's a number. This will convert to 0. It's not a number. And so these are the weird cases, right? But for the most part, if you are using prompt, nobody's going to pass in some of this stuff, hopefully, if they listen to instructions. Otherwise, there is further error handling you could add to it to check some of this other stuff. But a nice way to quickly check if our number is not a number and protect our code against it. So, all right, if we did this here, and we did this example already before, but if we had a case in here where we said, okay, is A not a number? And then we can use those logical operators, or is the double line, I don't know what that's called, whatever. If you remember, and is also like this, right? 2 of them, or is not a number for B. So if we have this case here, we can easily return something. We could say console log, whatever, we could say arguments, not a number found, exiting, whatever message makes sense to you, we could let ourselves know. We could actually throw an error here, by the way. You could actually throw an error, hard error, if you wanted to. It would show up in your console really loud, or you can log it, and then you could just return 0 or something like that, right? Or -1 or whatever you want to call. If it hits this logical check, it'll return out. So then it'll never hit here. It'll never further down cause any more problems because you've added some error handling in there. So if we run this here, that's fine. But if we added, say, two strings, run that, not a number exiting, return 0, right? Now maybe 0 is good enough. Maybe good enough for us. We could do -1, but that's good enough. And then the next case, if we had, we had two numbers or we had a string and a number, it would probably make it through correctly. So if we had 10, 44, whatever, run that. Then it passes that condition successfully and it returns there. Now, of course, you could wrap this in an else. That is a style, but sometimes you can eliminate the else because of this return statement. So if it falls in here, it'll return an end execution. At this point here, it'll exit out of the whole function. Exit out, exit out of function, right? If it doesn't exit out of function, then it just falls through this next one, which will return a value and then exit out as well. But you could wrap that in. You could wrap that in an else statement as well, if you wanted to. So a nice built-in feature there. So we kind of already talked about that one, but that's another good one. Again, you can look at the web docs on this. I'll help you out in your lab. Some of your lab work. Is not a number. Method determines whether the value passes not a number and is type number. So same deal. It's a little bit more kind of in depth there, but it uses the number.isNaN instead of the global one. But yeah, anyhow, it's the same as wrapping it in this way. So they're saying that this number.isNaN is a little bit newer and a little bit more robust, but same deal. It works the same way. There's no difference at this point. It probably does some error handling much better. So that's that nice built-in version. I had a video, but again, technical difficulties. I'll post these. They're short little clips, but we'll do without. I'll try to get my audio fixed. All right, so we can move on to the math object. So again, it's these are quick little things to know. I can't say that I always need them, but there are some cases that I need some of them, and I'll use them in debugging quite regularly. Probably the last one I use quite a bit. So math is one of JavaScript's global or standard built-in objects and can be used anywhere in your code, in your script. Remember, global scope contains a lot of useful things like the pi constant. I don't know why, unless you're doing some calculations on circles. Euleri's constant. I mean, I'm sure there's a lot of, the web and CSS was created by CERN, scientific community with that giant collider. So I'm sure they have use for all this math stuff, right? They have calculations, and it'd probably be great to have a built-in math object. Math library, because I know other languages where you need to go out and pull in libraries, whether it be date libraries or math libraries or what have you. There's so many pieces that you can pull in, but it's great that this is internal to JavaScript. So other functions that are useful, we might talk a little bit about floor, round, and ceiling. Kind of sound like what they would, but might as well know about them. So this is a quick one. It's a nice one. If you want to find the max from a list of numbers passed in, it can quickly find the max quickly. You don't have to write some sorting mechanism that goes through and compares everything, like we did in the previous lab. We did a whole bunch of comparisons, right, against three numbers. Here you could just pass it and it'll figure it out itself. It does take a different type of parameter we haven't talked about yet. It's a concept of an array, but we haven't got there yet. But you can pass that into math.max, or you can do some other things. There's talking about some other operators. Either of these methods can, however, fail when the array gets too high. But yeah, the point is that if we pass in, I think we had that example somewhere. I don't know, we could create another function here, or we could just do it inline here. We could just say max math. math.max, and I guess we said 3 numbers, 200, -2. If you remember, if you recall, we had a lab. Does that work? 1,000. So there it went through and it figured it out. And then I'm sure if we had a whole bunch of other numbers in there, let's see how many it can take, right? It's awesome. So it can do that work for us. So we don't need to write 1, 2, 3, 4, 5, 6 conditional operators plus more logic to figure out what this did in one line. So hallelujah. So math.max, and I would assume if you have the max, you're going to have a min. That's what I would assume. But also, before I get there, right, if you pass in, I guess the point is if you pass in null, which is not a number, it should give us 0. That's because it converts it, right? That's weird. Okay, what if I give it a string? Expectation is NaN, so not a number. All right, so that would mean if somebody snuck a string in somewhere, it would actually give us an error right up front, which we could handle. Great, so that's built in. So I'd assume there's going to be a min, because if there's a max, there should be a min. And oh, I'm continuing on. Okay, here's the markup. Here's the syntax parameters, a number or limited array of numbers. So 2 options there. Return value, the greatest of the given numerical value, or NaN if any given value is non-numeric. So math.max returns 27. Otherwise, it'll throw an error if there's something in there that doesn't make sense. All right. So min, all right. So if there's a max, there must be a min in the same way. Function returns the smallest or 0 or more numbers. So yes, you can pass it as a number of arguments. So same deal. Same deal that we had if we just go beside this one here and we just push in min, it should behave the same way. It should return not a number. Then it should also give us back -100 is the smallest number. So therefore, I don't need to go through and do anything more than that. So, right, you could pretty much, if you needed to, you could actually, you could have a function that just does that. If you passed in, okay, well, I have a function, I need to find which one's the minimum number, I could return max.min against A and B, or even A, B, and C, which I think we did before, and we had a bunch of if statements. So there we go. We have a named function somewhere that we could utilize now. We could actually call this in this fashion and say min number. Again, it's only triggered when I call it, right? So it's a way to kind of make some logic in there. So if I run this, is it going to run? What's going to happen here? It's not running, so it doesn't like something here. It doesn't like me. Doesn't like me here. Why doesn't it like me?
Okay.
Probably misspelled something. Maybe space in there. Math. Ah, you're right. There, I get a message back. Max is not defined, right? It's math. There you go. See how small it is? There we go. Math.min. I don't know why I was thinking max min. That's min max. It's a real estate agent where I live, min max. That's why. Max min. So anyhow, I could create a little functionality piece that I could pass around now. Now I have something I can use somewhere. I could pass it around now by reference if I wanted to. That's interesting. I could probably put some logical checks in there as well. But that's the power of a little built-in object, right? If you didn't know about this, then you would have to go and do a bunch of work just to do one line of code. All right, so pi is, you've probably looked at this, it's a static property on the math object. It's defined as a ratio of the circle's circumference to its diameter. If you remember geometry back in high school, you might remember this. Pi is approximately 3.14, and whatever else it is, 149, often represented by that Greek number. Okay, but the point is that it's part of this class. If you quickly need access to it, you don't need to type all this out and create a constant in your code. You quickly call this constant that is probably used in calculations at some point somewhere in other types of industries that I don't work in, but it's there for you and you just quickly call it and it represents that number there. However, that might be too big for you. Therefore, you might need to reduce the decimal count like we're doing on the exercises. Math Pal. So again, this should be a lot easier for you because we're going through this language and we're going to understand some of this stuff. I would like to throw a video up at some point, but it's not working, just to kind of break it up, but we'll go through it because the videos don't work. Power of another number. So again, where the base is the base of the number, exponent is the number by which it's raised to the base. Math.power2, so 5 to the power 2, 25, so on and so forth. You get the picture, right? 8 to the power of 64. Again, you can use those in any calculations you might want to, right? So math.pow, 5 and 2, was that it? Let's see what it does. 25 right away. So I don't need to write this deal, right? I don't need to, oh, doesn't like something. Yes, I don't have to write a function that goes through and does the, anyhow, it's crashing on me. You get the picture. All right, we'll keep going on this. So these ones, again, square root is exactly what it says it is, square root of a number. If a number is entered wrong, NaN is handled for you. So not a number is handled for you. Math.square root, where square root is a number. If you remember your math, 5 times 5 is square root, so 5 to the power of 2, so on and so forth. It'll, sorry, yeah, 5. The square root of 5 is, square root of 25 is 5, Jesus. I'm forgetting all the math myself here. It'll actually do that calculation on that, which I remember. It's probably some long way of doing that. I just remember memorizing some of this stuff. All right, ceiling. So this is a way of sealing up an integer. So maybe in one of your exercises you need to do something like this. Maybe not. You have to figure it out. So the ceiling, the CEIL is a method on the math object that rounds a given number upwards to the next integer. So it goes up. 1.3 rounds up to 2, negative 0.9 rounds to negative 0. That's interesting, negative 0. Anyhow, you know what? If you don't remember this math, it's taken care of for you. That's the great thing is if you forget some of the stuff. So take note, the negative numbers, that mean that this number will get rounded down towards 0 instead of the number's greatest absolute value. That's a mouthful. Floor. So floor is another one. So floor is a method on that math object that rounds a given number downwards to the next integer. So floor returns the largest integer less than or equal to the given number. So 0.9 rounds down the floor to 0. 1.3 rounds down to 1. Very often you sometimes will need something like this in some calculation. Not often, but sometimes you will, depending on the line of work, really. You could work for some government, you know, I don't know, government agency or company where they're doing medical equipment and you need very precise calculations. I had a video, doesn't work. All right, so this one, and this one's probably one I use the most. It's a little bit to talk about this one. This one, we're not going to get through this one in one slide, so we have to talk a little bit about this one here. The random one. So I use this one quite a bit in debugging. Sometimes you have caching going on in your browser, and sometimes you need to change something just so the cache kind of breaks the cache a little bit. So sometimes if I'm debugging, sometimes I just throw in a random number that randomly picks something to kind of help me debug sometimes in those cases. Give me some dynamic variables sometimes to work with. Hold on, there was a question here. Math.min, math to fixed, yes. All right, math.random. So generating random numbers, you know, I can't read that. Sometimes while developing projects, you'll find yourself looking for ways to generate random numbers. It's true. Most cases for generating numbers would be like game of chance, rolling the dice, shuffled playing cards, or spinning roulette wheels. If you were doing a gambling site, I'm sure this would be really useful for you. Sometimes you need to just randomly generate some key. Sometimes you need to, like I said, do cash busting or break some cash. There's lots of applications for it, really. Sometimes writing unit test cases, you might need some random numbers, of varying sizes. So this one's a good one. I use this one quite a bit. So the math object in JavaScript is another built-in object that has properties and methods for mathematical calculations. A common one is for random numbers. And this is the guide here that we may look at. Right, so let's quickly look at, so if I quickly ran this, math.random, oh, now I get IntelliSense there. Wow, I didn't have that before. Look, math dot, and you can see all the other ones I haven't gone through. So it has saved you a little bit of pain. I haven't gone through everything there. There's a bunch of other ones there like cosine, sine, tangent, stuff, things like that. Log, there's a bunch in there. This one's random. So if I just quickly run that, it's going to give me a random number. It's a good big random number. If I refresh it again, I'll get something else. And there's ways of controlling it, I believe. I'll have to look at the syntax again. 1 to 10. Is that going to do it? 10 decimal places. 2 decimal places. I should read the documentation. That's probably the next step. Or look at this example here. This one is saying 0 to 9. Okay, right. So sometimes you may need to convert some of those long-running numbers. So you may need to do something in this sense here where you're going to get a random decimal point. You're going to times it by 10. You're going to get, then if you notice, you might not like the format of that. So you have to combine it. You have to combine the mathematical built-in operators. That might be too big for you. Maybe you need to parse it up. Maybe you need to do the ceiling. I don't know, the math dot, what we're gonna do, ceiling, floor it. So you might need to combine something like that to give you something a little bit better. Let's see what that looks like. So does that look, that's 6 now. Okay, so if you see there, I got rid of all those decimal places. So I could do ceiling as well, which probably will round up, maybe, depending, it's random, right? So depending on the number. But you can combine these to get what you want. Probably in one of the examples as well, exercises, you probably will have to combine these things to get that that pi value trimming down. Right. Okay. So it's another built-in one. Just a quick reference to it. Again, you can read the web docs there. To kind of get another look at more examples of it. Math.random returns a floating point pseudo random number. By the way, I'm going easy on you right here. By the way, I could throw some topics at you, but I know there's an exam on Thursday, Friday. So I'm going over the math library. So if it's a little boring, just be happy that I'm not getting into something really crazy. This is a bit of a break in a sense. I think we can all understand what these functions are doing, and it's probably a lot nicer than getting into something like conditional looping or something like that right before the exam. So just know that. Just follow with me here, and then we're covering this, and it's a little bit easier for taking into consideration the hoisting thing I hit you with. So. Right, math.random. We'll get through this 5-6 slides, and then we'll get you back to your breakout rooms. And you guys can work on this stuff. Just kind of giving a little context to it, just so you know, so you don't have to look at the docs. So it doesn't exactly return a whole number, as we saw. It's a floating point value between 0 and 1. The value returned is a pseudo-random in nature, so just randomly generate. It might not. So random numbers generated by this might seem random, but those numbers will repeat. True enough, they do actually repeat sometimes. If you use it enough, you'll see the numbers kind of, it's chance. Sometimes you might get the same number at the same time, like on the next refresh, which if you're comparing state or something, it's weird, but it's random. It's totally random. There's some pattern it follows, but you know, it's like getting the same number in the lottery, right? Or the same digit. Maybe they use math.random for the lottery. I don't know. Because it's a generator, can never be truly random, blah, blah, blah. Yada, yada, yada. That's what they would say. All right, so random number generator function. So here's a nice function that you could use. I'll try to explain it. I'll try my best. But, you know, if you look at that quickly, you could say, okay, it is a random number. Give it a min and a max. It'll go and try to find out some random number between 1 and 100 or 2 and 70. And then the inner workings of it, I can basically look at that and say, okay, it's going to find a random number. And then it's going to times it by the min and max, some calculation there. And it's going to try to, you know, it's going to try to apply the rest of it to prevent the same kind of numbers showing up all the time. And then it's going to floor it because it probably doesn't want all those decimal places. That's what I can tell by just looking at that. But we can break it down a little bit to kind of explain it a little bit. So the math.random method will return the floating point number between 1 and 0. So we know it's going to be some long 0.99993. And then we have another interval that we're going to times that by to make it more random than what it is between a min and max. So between 0 to 100, 0 to 100 and I don't know what the lyric is. Drake said something about that. Min to max, right? So intervals would be as follows. So if you wanted to really get into this, to factor the second interval, so now we're just trying to figure out that calculation. Max minus min, it's going to try to give us, right, 100 minus 0, or what have you. So now to get a more random value, we'll do the following. So a random number times the difference of that, and then you store it in the variable x, the constant x. Just breaking it down, if you're still with me, you know, you don't have to really know the calculations, just trying to show you what that does. And I think that's the last slide. All right, let me move that to the end. So that is the random number generator. So like I said, you'll use this quite a bit when you're dealing with, you know, you're just dealing with state busting or when, you know, testing, and you need a random ID. Suppose you're testing a backend database, and maybe, you know, you have a bunch of keys, you know, 0 to a million if you have a big database, and you don't want to sit there and hard code the same number all the time. You want to be able to, you know, you want to be able to get some different kind of tests randomly to make sure that you have random data. So you can use a random generator and just, you know, as you do it, you can get different numbers. Oh, that's called 0. But yeah, you can do that. All right. All right, so that is that. Exercise 3. So if you're on 1, just work your way down, keep working. I'll put you back in breakout rooms because I think it's going to help you guys. So what I was getting at was exercise 4. So here was a functional expression that writes a function that returns pi. Again, that to me looks like you use the math.pi and then it does some type of you know, flooring or something like that. Anyhow, it creates that kind of representation. Now, if you don't get the exact thing, but you're close, you know, that's cool. This one was a little bit different. It was create a function that takes 2 numbers and a mathematical operator. So it's kind of like a mini calculator. You pass in the operator. You will probably have to do some type of logical flow to kind of figure out, is a symbol an addition, subtraction, division. I'm looking at this right now, and that seems like, you know, a few, you know, 4 or 5 cases there. You need to kind of handle some cases where, you know, it's not a number. So maybe you would use the NaN operator that we talked about, and then handle not numbers. And if you remember, we can also break the execution by using a return statement to return out. So you may have, you know, 5 or 6 different kind of logical operations in there, if statements, conditional operators in there. All right, so like I said, if you guys need more time, we'll give you 45 minutes in these breakout rooms. You guys can all help work together and submit your lab. And we'll be back at 9:15, all right? Okay, guys, let me set this up.